My name is Fatima, a PhD student from University of Passau. My research interest is improving graph algorithm using deep learning techniques. And today I'm presenting my current research that I just started this research a month ago, and today I present the intermediate result. But we have some idea to continue the work that I will discuss in future work. And the research is finding the shortest path between two nodes in the graph using deep learning technique. Let's have a look in outline. First of all, I have a short introduction to introduce the problem, and a little introduction about graph embedding, and then I will explain a little bit about current state of the art or recent state of the art. I will introduce our approach, and at the end I will show you some tables for experimental result and some charts. So what is the shortest path problem? If you look at this graph, you can see that the shortest path is the path with the minimum distance between two nodes. There are other paths, but the problem that we want to solve is finding the shortest path between two nodes in the graph. And this is a very important problem because right now some cable network company use this idea or for finding the best routers in the computer networking area. Google Maps, virology for disease, for infection, the spread of disease in the network of spread of disease in the biology, and also using less wires in VLSI design. So, if I want to define the problem formally, there are two types of shortest path problem. The first one is we have a source node and we want to find the shortest path between this node, start node, to other nodes. This is this problem called single source or shortest path. And the other one is we don't have a specific source node. We want to find the shortest path between all the pairs in the graph. That's the problem that I currently work is this problem. There are some exact method that in the literature that they try to find the shortest path between all the pairs in the graph. We can apply, there are some idea to apply the Dijkstra V times, which takes this time complexity, but if we have a dense graph, the number of edges would be the square, power 2 of the number of nodes in the graph, and then Floyd-Warshall suggested another faster way. But they are more recent works, but still they are expensive, and the idea nowadays is using some approximation method that we can approximate the shortest path. We don't, so for some problem, we don't need the exact value of the shortest path. If we can approximate value, would be enough. So the problem that we want to solve is finding approximation technique for shortest path in the graph that we would like.
We don't consider other heuristics like the A-star algorithm or the
heuristic.
If you know some other characteristics of the graph.
The heuristic approach or approximation approach?
No. Not obligatory. But you have the A-star algorithm if you know
but yes, but I think A-star is also expensive. It's QE.
I don't know the exact quantum, but it can take the properties of the social network into account. It is.
But there are many ways, but all of them are expensive because we want to solve it in linear time. So all other approach would be expensive regarding our approach. So we want to utilize graph embedding to solve this problem. What is graph embedding? The idea is finding a vector that can represent the property of the network and can preserve the topology of the network. And we can call it the encoder, that the input is a node in the graph and the output is vector with d dimension. If we consider the adjacency matrix of the graph, this dimension would be big as the number of nodes in the graph, but we use this idea to somehow reduce the dimensionality. And after finding an optimal vector for that represent the graph nodes, we want to use this vector to solve some problems in social network or in graph generally. For the shortest path problem, it can be the source node and this destination node, and the result would be a number. So there are some approach to embed to find a graph embedding for all the nodes in the graph, and some of them are based on matrix factorization, and there are some new techniques that use random walk. These first techniques, they optimize the vector regarding some pairwise proximity in the graph, and they are expensive. But these two recent techniques, they first do some random walk over the graph, and regarding the probability of co-occurring node in the random walk, they find the optimal vectors. And the positive point of this approach is they can find embeddings in the linear time. That we want to utilize this approach in our research. So some of current work to approximate the shortest path between all pair of nodes in the graph. Most of current approach are based on landmark based method. What is landmark based method? In this technique, they first select k nodes in the graph, this number is smaller than the number of nodes in the graph, and they call this set of nodes as landmark. And then using BFS, because BFS on the unweighted graph takes time complexity as number of edge plus number of nodes, and they use this to find all the distance between this k node to all other nodes in the graph. And then when they have a query like this, they want to find distance between two nodes in this set, like U and V. They just need to find the k that has connection to both of them, and this query would take k time, because they have to have a look in this set and find the k, and it takes k time. And then if they want to find all shortest paths between all nodes in the graph, it would take this time from the landmark, making landmark, and k times to a number of nodes power 2, because we have the maximum pair that we have in the graph is number of nodes power 2, and each pair takes k time, so it would be this time for all the pairs in the graph. And what is their contribution in this approach? The contribution is always finding the best set of landmark. That is NP hard problem, and they always come up with the idea this approach is just finding optimal set of k nodes. So then still the problem is cardiac, and it's expensive time-wise. So we want to find an approach that find the distance between all pair of nodes in the graph in a linear time. So our algorithm is like that. The input is a graph, and we want to, for all the pair in the graph, we want to find the shortest path. But if U and V are the neighbor and direct neighbors, the time complexity to find the distance between them is O1, because they are neighbor. But otherwise, we need a shortest path algorithm using neural network to find the shortest path between U and V. So I explain our idea step by step. First of all, we train embedding over the graph using DeepVac that takes OV, as I explained already. Then we select k number of nodes, which is and then we run BFS started from each node separately to all other nodes to have gather our training data. Then we would have k times to the number of nodes training pair. And then when we gather our training data, we have a feed-forward neural network to generate the distance and to train the network regarding these training pairs. And then we select from unseen pairs, because we just see these pairs, and we select from this set unseen pairs to test our approach. And it would take embedding time, this time for training, and this time for, because the time complexity for feed-forward neural network is O1, this time is for generating the distance, and it would be in linear time, because in social network, I specifically work for social network, number of edge is nearly equal to number of nodes, because it's a sparse graph. And then our approach would be faster than a state of the art. So the neural network that I use is a feed-forward neural network. The input is embeddings. The output is a number, real number. And in fact, it is a mapping function that maps embeddings to the distance.
Excuse me, the hidden layer, the cells of the hidden layer are not connected to all the cells of the input layer?
Sorry,
I mean, the cells of your hidden layer are not connected to all the cells of your input layer?
It's just a sample, it's not what I use.
Okay,
so it's fully connected.
Yes, it's fully connected. And hidden layer is a ReLU function, because I want to have a number at the end. I selected ReLU function as a hidden layer, and for the output I use soft plus, which is a smoother version of ReLU. Then these numbers would be the distance that I need. So I already explained how I take my training pairs. After I took the training pairs, the training metrics would be the subtraction of the embedding of two nodes that I want to find the distance between them. And this is the ground truth that I use. It's a NetworkX library that generated shortest path between A and B. So therefore, it is the input of the feed-forward neural network, which is the subtraction of embeddings of two nodes that I want to find the distance between them. And test set, I have two strategies to take the test pairs. First, I take pairs randomly from this set, but in this case, I wouldn't have enough samples for the high distance, like distance 8, 7, because in social network the distance is limited to 8, 7, 8, or 9. And then when I pick samples randomly, I wouldn't have enough sample for long distance. So I decided to take a set of nodes, and then again have the BFS to all of this other remaining node here. And again, same as training, the input would be subtraction, and the contours would be the real distance between nodes. So to estimate the error, I use 3 measures. First one is mean square error, root mean square error. The second one is mean absolute error, and the third one is I found it in one of the state-of-the-art that they find the subtraction between the prediction and the true value, and then divide it to the true value. And they call it approximation error. Yes. So the experimental result, I used 4 datasets. I selected this dataset by purpose. First of all, they are social network. I have limited distance between them, something like 8, 9. And then I also select different size of nodes to see how the feed-forward neural network react. And yes, for the YouTube, the distance are longer. Then I show you the results. When I pick pairs randomly, I got this error. But when I pick pair of nodes from starting from one single node to all other nodes, I got this error. You can see when the graph is small, I have acceptable error for all the measures. But when the graph get bigger, I get very high error, which is not acceptable, like 1.1 is not acceptable in our case. So I decided to visualize the error distribution to see which paths make a higher error. Because for Facebook with 4,000 nodes, the error gets worse. So I decided to visualize the error distribution. So in this case, the input of neural network is subtraction, the output is soft loss, and you can see when I have a larger error when the distance between nodes is longer, like 7 and 6, the error is get high. But for 3 and 4, I have acceptable error, but when the distance get longer.
Is it the error rate? You wrote error rate? Or is it the mean error in the distance? I mean, because your distances are from 1 to 7?
From 2.
From 9? No?
From 2 to 8, 9.
Okay, so but when you say the error, it is not regarding this distance. So
yes.
When, because you made error, you have been writing error rate. So when do you decide that it is the wrong distance? When it is not exactly the right value?
I have some measures regarding that measures. For example.
Yes, I understand. But when are you deciding that the mistake, the network is doing a mistake? When the answer is not exactly.
Maybe I made mistake. It's
okay.
Error value.
It's okay. So it's the error in the distance.
Yes.
Okay. So it is not a rate. It is not distance. It is not error rate.
Error value.
It is the error. No. But not rate.
Which term should I write here? You mean?
Yes. Yeah.
Because it's higher than
error.
1, so it's gonna
Error.
be
Yes. It is higher than 1.
Yes, so that's right.
Then I decided to change the input and output to see whether error gets lower. For example, I
just comparative to other techniques which are completely different, like you presented in the beginning, the error, the heuristics, the techniques based on the heuristics, the error is in the same range, or
they have less error.
they have less?
Their error is their error check state of the art. Their error for very large graphs, their error is in this range. But I have this error only for a small graph like this one, the first one. So I want to improve. This result is just intermediate result that I present in this workshop.
Although one has to say that the testing method is not the best testing method. So it was a Sigmod paper, but they still choose randomly pairs to test, and the randomly chosen number is rather low. I think for a big network they choose
1,000
pairs. Yeah. And that has the effect that most likely all nodes are if you look at the distribution of the paths, then you have either shortest path 3 or 4. And so it is not a perfectly fair evaluation. It was a paper by Weikon, so Max Planck Institute in Germany. So not sure if that is really so correct, so to say.
Study the completeness of the graph or the density of the graph have an effect on the result of node embeddings and so on, or the richness of the attributes you can attach to nodes have an effect on the quality of the node embeddings.
I applied other technique because I have deep walk and no two wake, and no two wake has more flexible random walk over the graph. I changed the parameter of the node two wake to test whether I get more feature regarding the graph structure, but it didn't help.
And so these are all social networks. We did not extend to any other kind of network types.
But if a graph is very dense, I don't know if it has an effect on the graph embedding quality. Or it's very sparse, or it's
not taking away the conclusions. I think it has, because the random walk properties are different, and actually, to be honest, the deep walk and node-to-back graph embeddings are very dumb methods to do things. There is a recent paper of
It's my future, but please don't tell me. I want to talk about it.
I don't tell it.
And so could it make sense to take only one data set, one network, and to suppress some of the edges and check the influence of
It's the future, but I will talk about it. Wait. So the basic method was having subtraction as input and a subclass as output, but I decided to change the output to the ReLU, but error is still high, and also the input, instead of finding the subtract between two embeddings, I decided to concatenate two embeddings, but still I didn't get a good result. And for future work, yeah, I don't know why when I do concatenation for 3 I get
there is a magic value for which it works very well.
yeah, I know. But still, I consider them the average, and for average, because I get higher error for the long distance, it doesn't improve. It's concatenation of two vectors, just concatenation. Maybe I write something. Do you have mark? Yeah. The first technique was we have vector A, the minus vector B, but the second one is just concatenation. Is somehow we have vector 1, vector 2, vectors concatenate, putting and consider it as one input. Yes. So future work, that's when I come back to FASO, I have to start implementation for that. I find this paper is hierarchical representation learning for network, that they claim that their approach preserve more property of the graph and more global properties, because random walks stay local. They are local approach, but they claim that this approach preserve structure of the graph. Maybe I show the paper here. I have to present it on Monday in FASO. And they divide the graph to different subgraph. They call it graph coursing. each step they remove some edge, and they make a set of subgraph, and then they do embedding for each subgraph step by step. I mean, they initialize embedding with GL, they produce embedding for one of the subgraphs, and then yes, in this step they produce embedding for a subgraph, and then in this part they try to initialize the network embedding by the embedding of the generated for this subgraph, and again they continue to produce one embedding for whole graph, and they claim that this approach preserves the structure of the graph, but I should implement it and use it to see whether it has influence in for estimating the shortest path or not. And the other approach is a new technique for embedding, point query embedding. That's their objective function is different than deep void and not 2-way. It's regarding some distance maybe I should show the paper. Yeah, they have this distance. And they optimize the vector embedding regarding this distance, which is hyperbolic distance, not geometric, not Euclidean distance. But I don't know much more detail about it because I haven't read it perfectly. So it's our future work. And
so these embeddings are somehow allowing to embed trees more efficiently. And since the social network is some kind of hierarchical organization, it was shown that you can have with fewer dimensions more information of the social network retained. That was Facebook research they did this year.
Tree structure of social network.
Well, not tree only, but hierarchical structures, that you have communities that are falling into sub-communities.
Hypergraphs in a tree.
Their embedding space is a ball, it's not Euclidean space.
Okay.
So it's n-dimensional ball. Okay, and we want to also try to have another layer on the top of the input layer to train embedding regarding the distance. I don't know if you understand it or not, because this is a network that produce the distance, and I want to add an embedding layer here to first initialize randomly to generate during the training. It would generate new embeddings for the distance. So I want to also try that approach. So that was all my work until now. And thank you very much.
Maybe one question. Maybe it would be interesting to study if there is a distance that change in the graph, not a new connection, but if a distance change, maybe it is possible to retrain with by adding a few examples and to still have good performances. And it will be an added value of this method, because I mean, if you have a graph, yes, but maybe it will change over time. I mean, the connections, the distances, the value of the value between and the graph.
But the shortest path, why the shortest path between nodes change? I mean, because the graph is dynamic and we have a new node between. Okay.
So new nodes are coming in, or nodes are
yes, and so maybe you can retrain with a few more, with only the examples that have. But it will be possible to identify the example. Yes, it will be nice to create examples that are best representing this change and to retrain. I don't know, but I mean, I think that with the classical algorithms, you have to do again all the work, and maybe it will be an added value of the artificial neural network approach, not to have to retrain everything in a graph that can evolve, because I think these social networks are not static. Yes. So it would be nice to be able to retrain, not starting from scratch.
What you could do, if there is an embedding layer, you could initialize the new node with a random embedding and then train just that embedding and keep the rest of the network fixed and static.
Okay.
That's a good idea. You also did experiments on artificial networks with Strogat's Watts generators, or no?
Not yet. This was for some social networks.
These are classes of artificial networks where you can also implement the expression for the distance and so on, so you get values which to compare. So you could analyze theoretically this equation. See how the algorithm performs.
But you did use graph generators.
No, it was for the previous publication.
I think it would be nice because maybe the neural network will be more efficient if there are some patterns of organization in the graph, because it will be able to generalize based on the fact that some part. So I mean, there is a pattern in the connection. I mean, connections, and for a completely random graph, maybe it will be very difficult to generalize anything. So I think maybe the approach can be quite dependent on the topology of the graph, and maybe it will be nice to generate many graphs with the different parameters and to try to understand for which type of organization of topology it is best suitable, and then people will be able to use this technique depending of the type of graph they have.
Yeah, that's a good idea.
The distance you're trying to approximate is symmetrical, right?
Yes, UV and V and U is symmetrical. Yes.
Okay. But with the neural network, the output of AB
should be same as BA. I tried to say it's the same.
Okay, so it's the same.
Yes.
So the distance goes in as an absolute value.
Yeah.
Yeah, but I mean, if you
The subtraction of A and B and B and A is the same thing that I put in the input.
okay, because you
Yeah. Absolute value of subtraction of two vectors.
And for the concatenation, it's true.